Chapter 4, Section 2. Writing equations in point-slope form. Have we talked about point-slope form before?
Yes.
No.
No.
We have not.
I have.
We collectively as a fourth hour class have not. Have we?
No, sir, we have.
What forms of equations have we talked about?
Slope-intercept form.
Slope-intercept form.
Standard form.
What is slope-intercept form?
Y equals mx plus b.
Y equals mx plus b. I heard someone say another form.
Standard form.
Standard form. What is standard form?
It's not AX.
That's my slope formula.
Is it AX plus BY equals C?
There we go. There's standard form. We talked about that when we talked about x and y intercepts.
Should I write that down?
But those are the only two forms we've talked about so far, correct?
Yeah.
Point-slope form is just another form of a linear equation. Okay? For slope-intercept form, what are the two things I need to create an equation in slope-intercept form?
Slope and y-intercept.
Slope and y-intercept, hence it's called slope-intercept form. So what do you think I need in order to write an equation in point-slope form?
You need
That's
the x-intercept as well.
Nope. Slope and a point. Any point on my line and the slope of the line. If I have those two things, I can write an equation in point-slope form. Okay? We okay with that?
Yup. You.
Okay. You don't necessarily have to write this slide down. This is straight out of the book. It's just an example showing you how they get to point-slope form. Okay? So just pay attention. Like I said, given a point on a line and the slope of the line, you can write an equation of the line in point-slope form. Consider the line that passes through the ordered pair 2, 3 and has a slope of 1/2. Let x, y be some other point on the line where x does not equal 2. You can write an equation relating x and y using the slope formula. What's our slope formula? y2 minus y1 over x2 minus x1. So using the slope formula with x1, y1 being 2, 3, and x2, y2 being this other point, xy. So there's the slope formula. If I plug everything in that it gives me into the slope formula, my slope's 1/2. y2 is just y. y1 is 3, so y minus 3. x2 is x. x1 is 2, so x2 minus x1 is x minus 2. And then you can multiply both sides by x minus 2 to cancel out that fraction. And this actually gives us point-slope form. Okay? So like I said, you don't necessarily have to write that down. That's just an example. That leads us right into what point-slope form is. I'll write it bigger. But a linear equation written in the form y minus y1 equals m times x minus x1 is in point-slope form. Write that down. You need to have that down in your notes. Write that down and write point-slope form next to it so you know what it is. Point-slope form, y minus y1 equals m times x minus x1. You need to have that one memorized as well as slope-intercept form. That way you know the difference between the two. Get it memorized. Y minus y1 equals m times x minus x1. We got it memorized?
Yeah.
All right, good. That's what I like to hear. You guys are fast learners.
I know.
Huh? Get it memorized, Sarah. So the line passes through the point, x1, y1, and the slope of the line is m. So we get our x1, y1 from the point that's given to us from the line, and we get our m as our slope. Okay? This y will stay as y. This x will stay as x. Those don't change. Okay? But the x1, y1, and the m will just become numbers based on the ordered pair we're given and based on our slope. We okay with that?
No.
What are the two things I need in order to create an equation in slope-intercept form?
Y-intercept and slope.
Y-intercept and slope. What are the two things I need in order to create a line or an equation of a line in point-slope form? A slope at some point on my line. Okay? Do we understand that concept? They're very strategically named based on what you need for that equation, right? Slope-intercept, you need a slope and a y-intercept. Point-slope, you need a point and a slope. Pretty easy, right? Guarantee you some of y'all will get those mixed up. Don't get them mixed up. Just because they both have the word slope in them. Think about it whenever you're doing it. Slope-intercept, oh, I need a slope and a y-intercept. Point-slope, oh, I need a point and I need a slope. Okay? Questions on what point-slope form is?
Nope.
Like we said on the previous slide, point-slope form is just derived from our slope formula. Okay? Can I move on?
Yes.
All right. Example 1. Write an equation in point-slope form of the line that passes through the point, -8, 3, and has a slope of 1/4. Now, I want you to always read the directions carefully. What form does it want our answer in? Point-slope form. Sometimes it might ask for your answer in slope-intercept form. And I'll show you how to get to that from point-slope form here in just a second. But for right now, for this example, all we have to worry about is point-slope form. What is point-slope form?
Y minus y1 equals m
Okay, there's point-slope form, correct?
Yeah.
Okay, what are the two things I need to create an equation in point-slope form? A slope and a point. Do I have those two things given to me?
Yes.
Yes, I do. So I can jump straight into creating my equation. Because they're both just given to me right away. So, in the ordered pair, -8, 3, is -8 an x value or a y value? X. So that's going to be my x1. In my ordered pair, is 3 an x or a y value?
Y.
Y value, so that's going to be my y1. So I just plug those two numbers in for x1, y1, plug my slope in for m, and I've got my equation. Okay? Does anything happen to that first y?
No.
No, it just stays as y. Minus, what's our y1?
-8. Or 3. My fault.
3, so just y minus 3. Equals, what does m represent?
1/4.
Slope. What is my slope in this case? 1/4. Times, does that first x change or anything? No, it stays as x. Minus, what's my x1? -8. Let's clean it up a little bit. Two negatives right next to each other makes a? Ooh, not there. Makes a positive. So it's going to turn into x plus a. What form does it want my answer in? Point-slope form. Is this in point-slope form? Yes, it is. There's my answer. That's all I need to do. Okay? Now, if you can recognize in your head that when you're subtracting a negative, it turns into plus, I'm okay if you jump straight to this. Does everyone see that? Like I said, if you can recognize that subtracting a negative turns into plus, I'm okay if you skip this step right here and jump straight to this. Okay?
Yeah, I know.
So if your x value or your y value is negative, that's going to be y plus a number, right? If your x value is negative, it's going to be x plus a number, like it is here. But if our y value is positive, it's going to be y minus a number. If our x value is positive, it's going to be x minus a number. Okay? Any questions about that? Yes?
So that's the answer?
Yep. Because it wants an equation in point-slope form.
Oh, I thought you just started solving it.
Nope. Is that in point-slope form?
Yeah.
Yep. And it's a line that goes through -8, 3 and has a slope of 1/4. So that's it. That's all I have to do.
I might have solved it.
Can I, that's why I want you to pay attention to the directions very, very carefully. So that way you know what form it wants it in.
Yes.
Can I move on?
Yeah.
All right. So when you are given 2 points on a line, you can write an equation of the line using the following steps. Step 1, find the slope of the line. What are the 2 ways 2 days ago that we found the slope of a line? My slope formula,
Oh.
y2 minus y1 over x2 minus x1. What was the other way we found the slope? If we were given like a graph or something.
Rise over run.
Or rise over run. You create that triangle, find your rise over your run. Right?
Yep.
So step 1, find the slope of the line, depending on what you're given. Step 2, use the slope and one of the points to write an equation of the line in point-slope form. Up here it says when you're given 2 points, you can follow these 2 steps. But it says to use one of the points to write an equation. Does it matter which point I use? No. Both points will be on the line, so they're going to give me the same equation for my line. Okay? So you can use either point you want. Any questions on these 2 steps? All right. Write an equation in slope-intercept form of the line shown. Did we read the directions carefully? What's special about the directions? Yes?
Slope intercept form.
And what's my answer in slope-intercept form, right?
Yeah.
What's slope-intercept form?
Oh, wait. Oh, my.
That's the form that my answer is going to be in, correct? Okay. What are the 2 things I need in order to create an equation in slope-intercept form? Slope and a y-intercept. Can I find the slope on this graph?
Yeah.
Yes, I can.
Yes.
Is it showing where it's crossing the y-axis?
Yes.
No.
Wait, no.
So I don't know my y-intercept, do I?
No.
So what equation, or what form of an equation do you think I'm going to have to use first?
Y minus.
Oh, my God, y'all wrong.
X2 minus X1?
I mean, we're going to use our slope formula, yes. But what form of an equation? Our slope formula is not a form of an equation. No. What are we talking about today? Point slope form.
Oh, yeah.
Can I find the slope? Do I have a point on my line? Yeah, I can use point slope form. And then we're going to convert it into slope intercept form. So this is where we're going to convert it to a different form. Okay? What's point slope form?
It's
Y minus
it's
Y.
y minus y1 equals m
Multiplied by X minus
parentheses x minus x1.
There we go. Y minus y1 equals m times x minus x1. Right?
Yeah.
That's the form I'm going to use first. So what's the first step I need to do?
Take
What's step 1? Find the slope.
yeah,
Right? Do you want to use your slope formula here, or do you want to use rise over run?
rise over.
Okay, we can use rise over run. And draw my triangle.
I'm gonna take steam on.
Okay, the height of my triangle is the what, and the width of my triangle is the what? Which one's which? Height is my rise, width is my
Run.
run. So the height is my numerator, the width is my denominator.
See.
Okay, let's find the height, the rise, the numerator. Count it with me. 1, 2, 3, 4. What's my rise?
4.
4. We'll get there.
It's going up.
Okay, let's find my run, the width of the triangle, the denominator. Count it with me. 1, 2.
Close.
My run is 2.
Right.
Okay, what does slope do? Say on this line going downhill from left to right.
Nice negative.
Nice negative. So do I need to leave it as 4 over 2?
Negative.
Negative. And what's negative 4 divided by 2?
Negative 2.
Negative 2 is my slope. We okay with that?
See.
Everyone okay? Everyone following along with me?
Yes.
Okay. Do I have my slope? Do I have my point? Let's plug into point slope form. Which point do you want to use?
3 negative.
3, negative 2? Y'all the first class that's picked that one. Everyone wanted to stay away from the negatives.
This is different.
So 3 is going to be my x1. Negative 2 is going to be my y1 for a point slope form. So I get y minus, what's y1?
Negative 2.
Negative 2. Is everyone okay if I just go ahead and put plus 2?
Yep.
Because it would be minus a negative, turns into plus. Right? Equals, what's my slope?
Negative 2.
Negative 2 times x minus, what's x1? 3. We okay with that? Questions about point slope form? that my answer?
Yeah.
Huh? Why?
It has to be in slope-intercept form.
Very good. I got to get my equation in slope-intercept form. So now I'm just solving this equation to get what by itself?
Slope and
Y. Trying to get y by itself. It's only going to take 2 steps, so it's not too bad. What's my first step?
Negative 2 times x.
Yeah, so what do we call that?
Distribute.
Distributive property. You got to distribute this negative 2 through here.
Yup.
What's negative 2 times x?
Negative 2x.
Negative 2x. Negative 2 times negative 3.
6.
Positive 6. We okay with distributive property?
Yep.
There's my first step. What's my second and final step to get y by itself?
Subtract.
Subtract 2.
Yup. I was just about to say that.
So I get negative 2x. What's the 6 plus negative, or 6 minus 2?
4.
Plus 4. That is now in slope-intercept form. Are we okay with that? Any questions on that? Okay? 6 minus 2? Oh, we don't subtract it from every single term. The only time we do it to every term is if we're multiplying or dividing on both sides. Okay? When we're adding or subtracting, we're just adding or subtracting the whole side, so we just combine the like terms. Okay? So this is my answer. It's in slope-intercept form, correct? So now I'm done with this problem. Questions? Can I move on?
No.
All right.
Was there so much?
Huh?
Was there so much?
Write a linear function f with the values f of 4 equals negative 2 and f of 8 equals 4. This looks similar to an example we did 2 days ago in our notes and to some stuff we did on the assignment from the other day. Anyone remember how I handle this?
Yep.
Yes.
It should be like fx equals some type of number.
Okay, this is function notation. So our answer is going to be f of x equals something.
Yeah.
Yeah, it'll be it. Our answer will probably be f of x equals mx plus b.
Right.
How do I handle this though?
You gotta like do the form, you gotta do that.
Very good.
Yeah.
In this first one, they replaced x with 4. So I know that's my x value for that ordered pair. F of x equals negative 2. So I know that's my y value because we treat f of x like y. So what's my other ordered pair?
8 and 4.
8 and 4. There we go. You guys remember that from the other day?
No. A little
No?
bit. A little bit. Just come on.
A little bit?
Can you remind me?
I just did.
Oh, yeah.
Okay. Do I have my information I need to put it in slope-intercept form here?
Yes.
Do I?
Yes.
Are you sure? I can find my slope, right?
Yeah.
Do I know my y-intercept though?
No.
No, because neither of my ordered pairs have an x value that's 0. Right? So I can't just go straight to slope-intercept form. What am I going to have to start out with?
Point.
Point-slope form.
Yeah.
Right? So let's find our slope first. y2 minus y1 over x2 minus x1. What's my y2, my second y value? 4. Bring your minus sign over from the formula. What's my first y value?
Negative 2.
Negative 2.
Add those together.
What's my second x value?
8.
8. Bring your minus sign over from the formula. What's my first x value?
4.
4. Two negatives right next to each other makes a positive. Stay, change, change. 4 plus 2 is?
6.
6. 8 minus 4?
4.
4. Am I moving too fast for anybody?
No.
Okay, how do I simplify this?
Divide by 2.
Divide everything by 2. What's 6 divided by 2?
3.
4 divided by 2.
2.
So my slope is 3 over 2. Can I erase my work from my slope?
Yes.
Yep.
Everyone understand that the slope is 3/2. Questions so far? All right. Now We said we're going to have to use point slope form, correct? Which ordered pair do you want to use for point slope form?
I said we go with 4 and the -2.
4, -2?
Keep it spicy.
I'll scratch this one out so we're not looking at it. Okay? So we're using our slope and our point 4, comma 2, comma -2. We okay with that?
Yes.
Okay. So I get y minus what?
Y minus negative, wait, no.
Yeah?
Yeah, -2.
-2, so it turns into y.
Y minus -2. No, plus.
Y plus 2, right?
Yeah.
If I do y minus -2, it's y plus 2. Equals, what's my slope?
3 over 2.
Oops.
Wait.
3 over 2.
Yeah.
Times what minus what?
X minus 4.
X minus 4, because 4 is my x value from my ordered pair.
C.
Questions there? The plus 2?
Yeah, look.
That's my y value from my ordered pair that I'm using. We chose to use 4, -2.
Oh,
So we did y minus -2, which turns to y plus 2.
okay.
Okay? Now we want it in that function notation, correct?
Yep.
So I need to try to get what by itself?
The X.
No.
You mean you get Y.
For slope-intercept form, I need to get what by itself?
Y.
Y, so then I can change it to f of x. Okay? So what's my first step to do that?
Multiply.
Distribute.
Well, distribute. Yeah.
What's 3 halves times x?
3 halves of X.
3 halves x. 3 halves times -4.
Let me use a calculator for this one, 'cause I don't know.
-6.
Oh.
It's mental math, guys. Come on, it's easy.
Come on.
It's easy. I'm just kidding.
I'm just kidding. I don't even know. I don't know how to do that.
Okay.
That's my best friend.
How do I get y by itself?
You
Subtract 2
Subtract 2.
from both sides.
Y equals 3 halves x. What's -6 minus 2?
Positive 8. No, negative 8.
Minus 8. Is that my answer?
Nope.
No.
Why?
Because
You put it in the wrong order. You put it in the wrong function.
Was he supposed to write
So I need to write it as...
Wrong form.
Yeah. So now I got to change y to f of x.
Of X. Indubitably.
now you got the right answer.
Is that my answer?
Yes.
Yes, it is. It's a function f with the values f of 4 equals -2 and f of 8 equals 4. If it wants a function f, you do need to use f of x. Okay? We okay with that? Questions on example 3?
Nope.
No, sir.
All right. Can I move on
Yeah.
to my last example? Uh-oh.
No!
Oh my goodness, it's a word problem. I hate word problems.
I do
not do
So you guys sound like all the time.
Sir,
Huh?
I don't do
We're about to do one. The student council is ordering customized foam hands to promote school spirit. The table shows the cost of ordering different numbers of foam hands. Can the situation be modeled by a linear equation? Explain. If possible, write a linear model that represents the cost as a function of the number of foam hands. A lot going on here, a lot that they're asking. What's the very first thing it asks? Nope.
Can the student's situation be modeled by a linear equation?
Can it be modeled by a linear equation? And to explain, how do I know if it can be modeled by a linear equation or not?
If it's in constant rate of change.
Yeah, I gotta look at my rate of change, right?
Yeah.
That's back from last chapter. Seeing if something's linear or nonlinear, I look at the rate of change. See if the x values are increasing or decreasing by the same thing each time. Also, the y values. See if they're increasing or decreasing by the same thing each time. So let's look at our table of values. Look at our x values first. From 4 to 6, what do I do?
2.
Oh, add 2.
Add 2, 6 to 8.
2.
Add 2.
Add 2, 8 to 10.
2.
Add 2.
Add 2, 10 to 12.
2.
Add 2. So my x values are increasing at a constant rate, correct?
Yup.
But I gotta have both x and y increasing or decreasing at a constant rate. So let's check our y values. 34 to 46.
12.
Add 12. 46 to 58. Add 12. 58 to 70. Add 12. 70 to 82. Add 12. Does this have a constant rate of change?
Yes.
So is this linear or non-linear?
This is linear.
This is linear. I'm not going to answer this question on the iPad, but I'm going to say it out loud. This is what you would have to write on your paper if you're doing this one on paper. Can the situation be modeled by a linear equation? I would say yes, the situation can be modeled by a linear equation. And why? Because it has a constant rate of change.
Yes.
And that'd be my answer for that question. Does that make sense?
So that's it? That's it?
I'm not done yet. That's just the answer to my first question.
Oh, okay.
Right? Yes, it can be modeled by a linear equation because it has a constant rate of change. So now I know it's possible to be modeled by a linear equation. So now it wants me to write a linear model that represents the cost as a function of the number of foam hands. Okay? Let's pick some variables for our situation here. For the number of foam hands, what variable do you want to use?
858.
Huh?
434.
Variable. What variable do you want to use for the number of foam hands? N. We'll use N for the number of foam hands. For our cost, what do you want to use for the cost?
D.
Huh?
D.
C.
D.
I like C better.
Yeah.
D is better. Dollars.
C is the cost.
10.
Right?
10.
So let's use N and C. So N is going to be like our X variable. C is going to be like our Y variable. Same concept, it's just going to look a little different because the variables are different. Okay? Now here, when we found the rate of change, what's another word for rate of change?
I don't know.
Starts with an S.
Slope.
Slope, thank you. Rate of change is my slope, right?
Yeah.
So I just found my slope. Remember, our slope is our change in Y over our change in X. Or in this case, our change in C over our change in N. So what over what?
12 over 2.
12 over 2. Which reduces down to what?
6.
6.
No. Yeah, 6.
12 divided by 2 is 6.
Yeah.
We okay with that?
Yeah.
That was easy. We already found our slope.
Indeed.
Do I know my y-intercept?
No.
No, because none of my x values are 0. Or my n values, right? So I don't know my y-intercept. So what form are we going to have to use first?
You already know.
What minus the number? You know, like, that 1.
What's it called?
1 minus 2.
What's it called?
So,
Let's go. It's points on form.
What are we, yeah, point slope. That's what we're talking about today.
oh yeah.
Point slope form. So for our case right here, it's going to look like this. C minus C1 equals M times N minus N1. Right?
Yep.
Because I took the C's out, replaced them with Y. Or took the Y's out, replaced them with C. Took the X's out, replaced them with N. Okay. It gives us 5 ordered pairs here. Which ordered pair do you guys want to use for point slope form?
10 and 70.
10 and 70.
70, okay.
Let's use that one.
Not a bad number.
Big
Not a bad choice. So C minus what?
70.
70. 'Cause that's my C value, right? Equals, what's my slope?
6.
6 times N minus what?
10.
10, because that's the N value I'm using. Everyone see how I did that?
Yep.
And let's go ahead and solve it for C. Get it into slope intercept form. How do I do that? What's my first step?
You would do
Distribute the 6 through. 6 times N?
6 and
6 N. 6 times negative 10?
negative 60.
Negative 60. We okay with that?
Yep.
And then how do I get C by itself?
Add 70 to both of the.
Add 70 to both sides. So I get C equals 6N
Plus 10.
plus 10.
Yeah.
So this is my linear model that represents the cost as a function of the number of foam hands. Any questions on that?
Cool.
So this is the same process and techniques we use throughout the whole notes, just applied to a word problem, right?
Yes, sir.
Yeah.
So you guys are good with word problems now.
Indeed.
We are
We are.
pretty solid with them.
Okay. Can I move on?
No.
No?
Yeah.
Yeah.
I'm ready to
Do we
do
have
it.
to change the
the X and Y.
That's different.
Usually when we're dealing with linear models, they're usually going to be a slope-intercept form. So I would want you to, yes. Can I move on?
Yes. No, let's-
Here's our assignment.
Oh, yeah.
Pages 189 to 190.
Let me take-
Numbers 2 through 34 evens. Due Monday, December 6th on Canvas.
Let me write this on.
I pressed.
Like I said, due Monday the 6th on Canvas. Tomorrow's assignment will be due Tuesday. Remember, I won't be here. You get an assignment with the sub. A pretty lengthy assignment over this stuff. Make sure on our today's assignment and tomorrow's, we're reading the directions to see what the form the answer wants it in.
C.
Sometimes it's going to be slope-intercept. Sometimes it's going to be point-slope. You got to read the directions and give the correct answer. If it asks for point-slope and you put slope-intercept, it's wrong. If it asks for slope-intercept and you put point-slope, it's wrong. Okay? Get it right. Get it right. Get it tight. Get it right. Get it right. Get it tight. Yeah, it's a song. Are there any questions about my notes before I end the recording?
You're